Okay, today we are going over 2.3, direct variation. So this is another type of linear function, and the difference between a direct variation and just a regular linear function is going to be the y and the x-intercept. So for a direct variation, it's always going to be crossing through the origin. So if it crosses through the origin, then we have the point of 0, 0. So if we have the point of 0, 0, then that means that the y-intercept and the x-intercept is both 0. So just like a regular linear equation, if we use y equals mx plus b here, which we know is in slope-intercept form, the slope being m and b being the y-intercept, we know that the y-intercept is b, which is 0 for a direct variation. So if we actually rewrite this, we know that your b is going to be 0, and therefore it'll just be y equals the slope times x. So we're going to actually use, instead of m for the slope, we're going to use a constant of variation, which will lead us to our next slide here, which is k. So k is going to be your constant of variation. So our direct variation equation is y equals kx. And if we wanted to just solve for k here, when we're trying to find our constant of variation, we would take this equation, y equals kx, we would divide both sides by x here, and then we'd get k by itself, leaving us with dividing our y divided by our x. And we can remember this because we know that for slope, we always have the change in y, our rise, this is always our rise, over our change in x, our run. So it's the same as your slope. We know that our slope is rise over run here, or your change in y over your change in x. So this isn't a new equation. What it's doing though is, since we know for a direct variation we're using the origin 0, 0, there's nothing to subtract here. If this is a 0 and this is a 0, then it's just dividing your y over x. And in the end, you really only need 1 point to find your direct variation because you already have this other point here. Moving on, we can identify direct variation from a table. So it can ask you two different ways here. It could say, determine whether y varies directly with x, which is the same as saying, is this a direct variation? Okay, determine if it's a direct variation, or determine whether y varies directly with x. These mean the same thing. If so, find the constant of variation, which is k, and write the equation. So we know from the previous slide that we just had y is equal to kx, and to solve for k, we are going to divide y over x. That's how you find your constant of variation. So if it's the same for every ordered pair, then it's a constant of variation and y varies directly with x. So let's try that here. We know we're using k equals y over x for each one here. So we have 8 over 2, that's a 4. Make sure you do the y over the x. 12 over 3 because it's rise over run. 12 over 3 is a 4. 20 over 5 is also a 4. So since we got every value of your constant to be a 4, it means that it is a direct variation. And then we can write the equation, sorry about my bad handwriting, then we can write the equation by plugging into y equals kx here, and therefore we get y equals 4x. So if you actually graph this, you'll find that these points lie on this graph. Okay, moving along here, if we try and do the same thing, y over x, then we get 4 over 1, which is just a 4. We get 7 over 2, which is a 3.5. And we get 16 over 5, where 5 goes into 16. 3 times with 1 left over, 3 1/5, which is the same as 3.2. So as you can see here, these are all different values, which means this is not a direct variation. DV standing for direct variation. So this one is not a direct variation because it did not satisfy the k equals y over x here. All right. Identifying direct variation from an equation now. So the same kind of thing. We want to just look at the equation here, determine whether y varies directly with x, which is the same as asking if it's a direct variation. If so, find the constant of variation. So we want it to look like this, y equals kx, where k is the slope or your constant of variation, and your b, which is the y-intercept, is 0. Keep that in mind there. So notice here, your y is by itself. So if y is by itself here, we want to make it look like this equation. So in order to get y by itself for this one, I'm going to divide both sides by 3, cancel this out, and therefore get y is equal to 2/3 x. We look here, they look similar, and therefore the constant of variation k is 2/3. So this is a direct variation. This one here, if you notice, your y-intercept, which is the value of b when it's in slope-intercept form, is a 3. And in order for it to be a direct variation, we need your y-intercept to be 0. So therefore, this is not a direct variation. All right, this one here, using a proportion, it's really the same thing that we've been doing. We know that k is equal to y over x. So all you're doing is you're setting it up. Y over x equals y over x. We know that all of the k's should be the same. Just like here when we divided them, all of these y over x's, y over x, should be the same. 8 over 2 should equal 12 over 3, which should equal 12 over 5. So you're doing the same thing with this one. And solving for the missing variable. Okay, so it's telling us suppose y varies directly with x, which means it's a direct variation, and we're going to just plug into this proportion. So we have y over x, so I'm going to plug in this first point here, negative 51 over 27, and we're going to set that equal to this point here, negative 17 over x sub 2. Whenever we have an equation or a fraction equal to another fraction, we cross multiply. So we're going to cross multiply here. I have negative 51x. I'll just write it as x. You can write it as x sub 2. We'll just put that in actually so we don't get confused. Is equal to 27 times negative 17. And then it's just some quick algebra here. We have negative 51 x sub 2. Is equal to, multiplying these out, that's a negative 459. Negative 459. Dividing both sides by negative 51. And we get x sub 2 is equal to negative 459 divided by negative 51 is a 9. And that's what x sub 2 is, 9. Okay, we'll do one more of those. It's very similar to the previous problem, setting it up the same way. If y equals 4 when x equals 3, make sure that you have it as y over x. Then we'll set it up as 4 over 3 is equal to, find your y when x is 6. So y over 6. Cross multiplying here, 4 times 6 will be equal to 3y. So we have 3y equals 4 times 6, showing the work. We get a 3y is equal to 24, dividing both sides by 3, and we get y is equal to 8. And that's all for today. That's 2.3, direct variation. Thanks for listening.